Hi, today we're going to work on 11.5 formulas and further applications. Today's problems are we're going to be solving for specific variables. On example 1a, we have area equals pi r squared. It's the area of a circle. So what they want you to do is they want you to solve for r. So my goal is to get r by itself. In order to get r squared by itself, I need to divide both sides of the equation by pi. So you end up with r squared equals a over pi. Now, in order to get rid of a square, we know from prior problems that we have done in the past, you square root both sides. So you're going to get r equals, don't forget, plus or minus the square root of a over pi. Now, because we're talking about radius, the radius cannot be negative. So the only possible answer would be radius equals the square root of a over pi. Pi is just 3.14 if you want to be technical about it. But we got r by itself. Now for 1b, they have s equals 30 times the square root of a over p. For a, they want you to get a by itself. Now, right now, you cannot get a by itself. You need to get rid of the 30 first. So what I'm going to do is I'm going to divide both sides by 30. So I get s over 30 equals the square root of a over p. Now, from prior time before, to get rid of a square, what you do is you go ahead and get rid of a square root, you square both sides. So I'm going to square this side, and I'm going to square this side. So I end up with s squared over 900, because 30 times 30 is 900, equals a over p. Now remember, I want to get a by itself. So if I multiply both sides of the equation by p, these p's will cancel out and I'm left with a here. Now if I multiply this side by p, I've got to multiply this side by p. So I'm going to end up with s squared times p all over 900. So this is the answer to this one, and this is the answer to this one. All right, next problem. The next problem says this: solving for a specific variable. On this one, they want you to get t by itself. So what we're going to do is we need to get t by itself. We are going to, well, I guess we can get, we can do the completing the square. That would work fine. And if you complete the square, you want all the variables on one side and the constants on the other side. The constant right now, even though we don't know what it is, it's a negative k. So I'm going to put that over to the other side. This is going to leave me 2t squared minus 5t. You know what? I don't want to use completing the square on this because it has a odd number in the middle, and it would be a fraction, which would not be fun to do, like none at all. So what I'm going to do on this problem is I am going to use the quadratic formula. I think that would be easier. So I'm going to go ahead and use the quadratic formula. I don't like completing the square if the number's odd in the middle. It'll take forever for us to do. So a equals 2, b equals negative 5, and c equals k. K is my constant. So I'm going to go t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So all we have to do is plug and chug. B is negative 5. B is negative 5. A is 2. A is 2. And C is K. Remember, it's just a constant. No big deal. So T is equal to a negative times a negative is a positive, plus or minus the square root. Negative 5 squared is 25. Negative 4 times 2 times k is a negative 8k, all over 4. And there you go. You have Oops, I don't know what I just did, but let me see if it'll come back. Yes. All right. Oops, it's not letting me subtract it. It's okay. I was going to try to make it neater, but it wouldn't let me. All right, so t is equal to 5 plus or minus the square root of 25 minus 8k all over 4. All right, next one. Next one is solving problems using the Pythagorean theorem. Now on this one, I would draw a picture first. So I have a building. So here's my building. So there's my building right there. All right. A ladder is leaning against the house. So my ladder is right here. And it is a distance from 5 feet from the bottom of the building to the ladder. Okay, so this here is 5 feet. Let me do a different color. So the distance right here is 5 feet. Now this forms a right angle, which means we can do the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. Something from geometry they expect you guys to memorize. The distance from the top of the ladder to the ground is 1 less than the length of the ladder. Well, you guys, we don't know what the ladder is, so I'm going to call it x. I have no clue what the ladder is. But I do know that the distance from the top of the ladder to the ground is 1 foot less than the length of the ladder. So this part here is going to be x minus 1, all right? So basically I have a right triangle. Here's a right triangle. This would be A, this would be B, and this would be C. So we're going to use the Pythagorean theorem to help us figure out how long the ladder is. So my a squared, let's just call x minus 1 squared, because that's your a, that's your length, the height of the building, plus 5 squared, that would be considered your b, and then the hypotenuse would be x squared, because that's going to be your c squared, which happens to be x. So what you're going to have to do is you're going to have to do a bunch of math. You're going to have to multiply x minus 1 squared. Now remember, this is actually, if you want to do the math over here, that means I have 2 of these. You're going to multiply them out, and you're going to end up with x squared minus 2x plus 1 when you actually do the math. So this is going to be x squared minus 2x plus 1, and then 5 squared is 25, okay, equals x squared. Now remember, you want to move everything to one side of the equation. So I'm going to go ahead and subtract x squared from both sides. And I'm going to be left with negative 2x plus 26 equals 0. You're going to minus 26 from both sides. Remember, you want to find out what x is. And I'm going to divide by 2. I'm almost finished, Mom. And I'm going to get x equals negative, actually it's going to be a positive 13, because a negative divided by a negative is a positive. And of course, distance can't be negative. So the length of the ladder is 13 feet. All righty. Okay, let's see what next one I have real quickly. This one is considered a reflecting pool. And what they do is they give you the dimensions of, so you have a pool and you have x's on each side. Those x's is going to be in the same x, because those are the lengths of the new grass area. Now, what you got to do is you got to find out what the area of the pool is, and then you got to find the area of the entire expansion, and then you are going to subtract them. So hold on 1 second. Sorry. And I'll just keep going. You guys don't mind a little bit of music? All right. So what I'm going to do first of all is I'm going to find the area of the large rectangle. The large rectangle, remember there's an x here and an x here, so that means it's 40 plus 2x, because you have x's on both sides. So you're going to find the area of the large. So the area of the large rectangle will be 40 plus 2x times, then you're going to do the width part, which is 20 plus 2x. Once you do that math, you're going to subtract it. You're going to subtract the area of the pool, and the area of the pool is 40 by 20. So it's going to be 40 by 20. And that is going to give you the area of the grass. So the area of the grass would be, I'm just going to put the area of grass. Okay? So what I'm going to end up doing is this. Oh, by the way, they gave us the area of the grass in the earlier problem. The area of the grass is 400 square feet. So that's what this part here is going to be. I said 700, right? Yep, 700. Okay. So this is going to be 700. What you need to do is you need to multiply 40 plus 2x times 20 times 2x first. So I'm going to do that now. And I'm going to get 800 plus 80x plus 40x plus 4x squared. Combine like terms, and you get 8, 9, 10, 11, 12. That's 120x. And you get plus 4x squared. Minus 800 equals 700. Now, if you notice this, got to clean up one side of the equation before you start moving anything. That 800 minus this 800 means that they're gone. So you're left with 4x squared plus 120x. I'm going to bring this 700 over to the other side, which makes it a negative 700 equals 0. So now in this part, you can use the quadratic formula if you want to, but what I'm going to do to just make this a little bit less work, I'm going to divide everything by 4. Okay, so I'm going to get x squared plus 30x. I have no clue what that part is. 700 divided by 4 is 175 equals 0. Okay, now you can use the quadratic formula if you like, a negative b. I personally would use completing the square. I don't know about you guys, but I would use completing the square because the numbers are really large. And since 30 is an even number, it just makes life easier. So I'm going to go x squared plus 30x plus something equals 175. I moved the 175 back over to the other side. And so what you're going to do is you're going to make this here. This is all just from the prior lesson that we did completing the square. My variable is x. Half of 30 is a positive 15. 15 times 15 is 225. So I'm going to add 225 to both sides. And then I end up with, I don't like the way that looks right there. I don't want you guys to get confused on that later. I'm just going to go like this. So then 225, that's 0, 0, that's 400. Now, to get rid of the square, I'm going to square root both sides. So I'm going to square root this side, and I'm going to square root this side. So I get x plus 15 equals plus or minus 20. Now, I'm going to subtract 15 from both sides. And I get x equals 20 minus, well, let me just rewrite it real fast to make it a little bit easier for you. And it's going to be a negative 15 plus or minus 20. If I were you, I would write it out as negative 15 plus 20 or negative 15 minus 20. Well, your two answers are going to be negative 35 and a positive 5. Everybody knows that this x value cannot be negative 35 because you can't have a distance that is a negative number. So your x is going to be 5 feet. So this little x, this little distance right here is going to be 5 feet. All righty? And then that's how wide this strip of grass will be. And I don't want to go out any further than this. I would like you guys to look at example 6 on your own.